Welcome to Calbeckistan, a place where anybody can learn math. I'm Mr. Calbeck, and today in our crash course series, we're going to be talking about something called compound inequalities. Let's get started. So when I say compound inequalities, what I'm really talking about is I'm taking multiple inequalities and I'm putting them together. Compound means more than one thing put together. So the way that we combine inequalities is with two words. This is one of the few situations in math where you're actually going to have a word. These are not variables or anything else. These are actual words and they mean the things that they mean in normal life. So I'm going to give you some examples and hopefully this will help clarify. Before we understand how we combine multiple inequalities, we need to understand what these two words really mean. The first one we're going to look at is or. The word or, when I'm talking about this, you think about it like a pizza. Do you want pepperoni or sausage? You tell somebody that's going to get pizza, and you're like, surprise me, get pepperoni or sausage. And they come back with the pizza. The pizza might have one topping of pepperoni or a different one of sausage. You're going to be happy either way. Okay, so there's multiple right answers for this one. With and, if you said, I want pepperoni and sausage, you're hoping that your friend will get both toppings on the same pizza. You need to have pepperoni and sausage on the same one, or you're going to be upset. Like, dude, I wanted pepperoni and sausage. You just got me pepperoni. That's not what I wanted. I wanted both. The word and is a combination of multiple things. It's the overlap where you need both different things. So with or, we have multiple right answers. With and, you have one right answer that's a combination of where they overlap. And that's what we're going to be looking at. So we'll start with an or problem, and you'll see how this works. All right, so here's an example of what you might see on one of your problems. Again, you see two inequalities that are combined with this word or. And really what you do is you solve them both. Okay, so some of these are going to be pretty easy. Some of them you'll have to do a little bit of math. But for this one, it's pretty simple. I just have to solve 3 right here to divide both sides by 3, and I get x is less than or equal to 2. And then I've got this other one. Now remember, or, there's multiple right answers. So what you're going to do is you're going to graph everything because anything that has an answer is going to be right. So the first thing I'm going to do is I'm going to say x is less than 2. So I'm going to follow my graphing principles. If you haven't watched my previous videos about graphing inequalities, you might want to take a look at that if this is confusing. Got an open dot here, and the inequality is going to the left because I want all the numbers less than 2. That's not a very good dot there. Let's try again. About right over the 2. There we go. The other one, I've got x is greater than or equal to 5. We have a filled in dot because it includes the 5. And I want all the numbers bigger. Now notice with this one, I have 2 right answers. Pepperoni or sausage. They could be going either direction. Either way, I'm happy. So with or, you have multiple right answers. Anything goes. And so you graph all of it. If my x is less than 2, I'm happy. If my x is greater than or equal to 5, I'm happy. With an or, you're graphing everything. Now let's see what this would look like with an and problem. All right, and we see the same kind of question on this one with an and. I have 2 different problems with the word and connecting them. This is going to look a little bit different though. So if I look here and I've got an x, I could just solve this one really quickly, dividing by 6 on both sides, and I get x. Remember all of your other rules for inequalities. Remember, if you multiply or divide by negative, you do need to reverse your inequality. So don't forget all those other rules about inequality still apply here. And now I'm going to graph both of them. I've got x is greater than 3, so it's a filled in dot because it's greater than or equal to. I want all the numbers that are bigger than 3, so my arrow is going to go this direction. And I have a 6 is greater than x, which means my x is here, an open dot. And I kind of see these arrows are passing each other. Now, if I were graphing an OR problem, I would graph everything, and this answer would actually be all real numbers. There would be no limit on what x could be, because the arrows pass each other. The difference here is that I have the word and the word and tells me that I want both. I want the place where they overlap. I want pepperoni and sausage on my pizza. If I only have one, I'm not going to be happy. So over on this area is x is less than 6. That's true, but it also is not where x is greater than 3. So I actually don't want this area over here. And up above 6, yes, it's greater than 3, but it's not less than 6. So I'm actually left with this area where they overlap, where I have both things that are true. And generally the way that we graph this, instead of graphing two lines that overlap, we have these lines connect. Like that. You're looking for the place where they overlap. All right, so let's see if we can graph this one. Remember, this is an and question where I want the things where they're both true. I want pepperoni and sausage on this one. So I'm going to graph both of these. There's no math to do on it, so it's just a quick math question. Again, many questions will require math on both of these, but let's just see what happens here. So I've got x is greater than 2, open circle, all the numbers greater than 2 are that direction. I have x is less than or equal to -1, all the numbers that are less than -1 are here. And you'd be very tempted to say, okay, I'm done. My arrows go opposite directions. However, here is the difference with an and. Remember, and I want both things to be true at the same time. I want the overlap. Here, there is no overlap. Since there is no location where both inequalities are true, the answer to this one isn't this graph. The answer to this one is actually no solution. Because there is no place where both of the inequalities are true. You need to be careful with this, making sure you're looking for it. Ors, remember, can go in any direction that they want to, and though we have to have an overlapping area or you have no solution. So make sure you look for that. All right, here's another example. Now this one, you might be looking at it right now and saying, well, how is this a compound inequality, Mr. Calbeck? There's no words in it. There's no and or. Which one is it? You're right, but this is a compound inequality, and I can show you why. There are two inequalities here. Since there are two inequalities in the same problem, this is still considered a compound inequality. Now, with a problem like this is actually a secret and question. If you ever see a compound inequality with multiple inequalities and one long expression or inequality like this, then that always means and. So it might be helpful for you to go ahead and write the word and right above the top here. If you can do that, you can remember we're still looking for that overlapping area. Now the question is, how the heck do you solve something that has two inequalities in it? Let me show you. The first thing that you want to do when you're solving this is to break this up into two questions. Now, there's this middle area that is in both inequalities. You have the -3 is less than this, and then 2x minus 5 is less than 7. So what I want to do is break it up into two inequalities so that I can solve each of them. Please don't try to solve this in one big horrible thing. Break it up like I'm going to show you. So what I'm going to do here is this is going to split into two questions. And we've actually done this in other videos where we've broken up a problem into two things. If you look at my bonus video on solving, episode 10, you'll see a similar process. But we've got here -3 is less than or equal to 2x minus 5. Again, there's one inequality. My other inequality is going to be this, but it's less than 7. So 2x minus 5 is less than 7. And I find it very helpful when I write these in a new situation to go ahead and write that word and in here. It reminds me of what I'm doing and how I'm going to graph this. Once you have your two inequalities, now you can solve them and graph them just like you would any other problem. Let's go ahead and do that. I think you guys know how to solve stuff, so I'm going to speed this up. Find both sides. 2x is less than or equal to less than 12 by 2. X is less than 6. In this one, we add 5. I got negative s or positive 2 with less than 2x, multiplied by 0, and I get x equals. So that's our 1. All right, and I've solved both of these. Notice that I solved them separately. There's no overlap. Once you break it up into two equations, you can do that just like you would any other inequality. Do them separately. You get two answers, and I'm going to be looking for that overlapping section. Go ahead and graph this. Remember, I've got x is greater than 1. I want all the numbers bigger than 1. That arrow is going to go this way. And I have x is less than 6. That arrow is going to go this way. And I care about where they overlap. The intersection point of those two lines. That's what I'm looking for because it's and. So I'm going to go ahead and connect these and make sure that it looks like that. Those are the different kinds of compound inequalities you are likely to see. You have and, or, you can have no solutions. With and, you can have ones that look like this. Remember, all of the same properties apply if you are trying to graph compound inequalities, but you are not certain of how to actually go about solving an inequality. Please watch my previous video where I talk about that. Thanks for joining us today on another crash course video. And remember, when math is getting challenging out there, remember, you guys can do this.